zeros of polynomial functions. It says if f is a polynomial function, then the values of x for which f of x is equal to 0 are called zeros of functions. And then these values of x are the roots or the solutions, okay, of the polynomial function f of x equals 0. All right. Each real root of the polynomial equation appears on an x-axis of the graph of the polynomial function. So this is something that you've already done, okay? But now with polynomial functions, we're talking about, okay, we're going to identify some points along the x-axis, okay, or which is the x-intercept, because remember, x-intercepts are all the points that's on the x-axis, okay, and those are called roots, or we can use the word solutions, okay. So let's do the first part here. Example 3, we'll talk about the multiplicity and x-intercepts. We'll talk about that in a few seconds. But let's look at the first part. Example 3, find the zeros for each polynomial function. Okay, so we're going to do that first. We have f of x is equal to x cubed minus 12x squared plus 36x. Okay, now even though it didn't ask you to do this, but what would be the end behaviors? End behaviors. What is n? It's 3, which is an odd. And what is the leading coefficient? Is 1, so it's positive. So what would be your end behaviors? There you go. Yes. Okay. So at least we have a visual of what the end. We'll do the middle part, and that comes with the roots, the solutions. We'll do the middle part. We'll talk about the even multiplicity and odd multiplicity. Okay. But let's first find your roots, your zeros. Okay. So what we have to do is, what do we know about finding the x-intercepts? Remember that? We have to what? Well, we're going to have to set this equation equal to 0. So we have x cubed minus 12x squared plus 36x equals to 0. How will we solve it? Factoring. We're going to, that F word, we're going to factor, okay? So, factor out of GCF. Can we do that? What is it? X. So we factor out an x, we have x squared minus 12x plus 36 equals to 0. Then we're going to factor x squared minus 12x plus 36. We get, here are two parentheses. We have x and x, 6 and 6, and minus and minus. And because x minus 6 is repeating, we can write it as a binomial squared, write it as the exponent. So you're saying here x times x minus 6 squared is equal to 0. So we haven't finished. We factored it. Now we need to find what is x. So by using the zero factor property, we're going to set each factor equal to 0. Well, we have one solution, x equals to 0. We can't go any further than that to just say that it's 0. Okay? Then x minus 6 squared is equal to 0. To solve for x, we want to take the square root to both sides. We have x minus 6 is equal to 0. Add 6 to each side. X is equal to 6. Okay? So, what this is saying, just as a visual for a second, okay? You can draw this if you want to. You don't have to. I just want you to see this. So here are our roots on the x-axis at 0 and at 6. And we know that we have our end behaviors, something like this for right now. Now we need to do the middle part. How is it going to curve or do some things there? Okay? Alright, so this is where the next term here, multiplicity and x-intercepts. It says if r is a zero of even multiplicity, then the graph touches the x-axis and turns around at r. Now I'll talk about what r means, okay? Then it says if r is a zero of odd multiplicity, then the graph crosses the x-axis at r. So I need you to understand when they're talking about, when it says crosses or touches and turns around. Now some textbooks, instead of using the word touch, they use the word bounce. I can kind of visual bounce them more so than just, touch. And it says and turns around. But bounce, I can think at least it bounces off that number and then it's going to jump around, still touch and turn. Okay? I just think bounce is just much easier. But what this is saying, so if it says something like, I'm just making up something that we'll talk about the multiplicity and I'll give you the terminology. When it says touches the x-axis and turns around, it says something like, okay, the line is going here, and instead of going through, this is through, or this is crosses the x-axis. That's not what we want to do. I'm just saying this is what cross means. But when it says touches and turns around, okay, that this graph is doing something like this, then it's going to touch at 6, but then it's going to turn around. It's not going to keep going through the X solution, trying to get out. Okay, so it touches, but it's going in the opposite direction. Okay, but if I said it's going to cross, then that means it's going to go through that number. Okay, through that solution. All right, so to determine if at 6 and 0, if it's going to touch, or if it touches and turns around, or if it crosses the x-axis, we're going to have to look at the multiplicity of an x-intercept. And here we go. Write this down for me. The multiplicity of an x-intercept is the power of the factor that gave you that x-intercept. So the multiplicity of an x-intercept is the power of the factor that gave you that x-intercept. So what this is saying, in effect, it is how many times you got that x-intercept. Okay, so I can say x-intercept, or I can say our zeros. I'm going to make this into a table just for me. It was just visually for me to see it this way, for me to understand it. I mean, because some textbooks had it everywhere, and I had to break it down and say, okay, how can I get this for me to understand it and for me to relate this to you? So we have our zeros are, when we solved it, we found a solution. Our roots are, okay, 0 and 6. So the multiplicity of our x-intercepts, which are 0 and 6, it wants to know how many times did I get 0? How many times, or how many times did I get 6? get that x-intercept. So this is where we can go back to the original question, or somewhere within the solving of it, it would tell us how many times. And we have to look at the power. That's where it says look at the power. So how many times did we get 6 when we had x minus 6? 2 times. How many times did we get 0? 1. There's an exponent there, so it's an understood 1. So 1, 0, and we had 2, x minus 6, x minus 6. We don't write 2 6s on there. On the graph, it's just 6. So, now, this is where, go ahead. There we go. All right. Now we want to determine if it crosses. Will it cross at 0, or will it touch at 0, touch and turn around? We want to know if it's going to cross or touch and then turn around. So how do we determine that? We determine that by the multiplicity. And it says if or when our number is odd, then it's going to, what does it say at top? I know it's kind of blurry here. It's going to cross. So at 0, when we get to 0, we want that line to cross or go through 0. And then it says at 6, we have a multiplicity of 2. That's even. What does it say when it's even? It touches the x-axis and turns around. Okay? So I know that this is not the... Okay, here we go. I know that when I draw this line, it's going to cross at 0. Somewhere it's going to go up, and then it's going to go down to 6, and it's just going to touch, bounce, and move up that way. That's what this is saying. Now, you can enter this equation into your calculator. I mean, I know this is not drawn to scale, and I mean, we have somewhat of a visual. It's not exactly like the graph and calculator, but at least you would know, because I'm going to tell you now in Math Excel, you're going to have 4 graphs to choose from, and you need to know first, look at the end behavior so we can delete some of the choices, and then we'll look at our zeros, okay, and our intercepts here. And then you'll know if it bounced at 0 and crossed at 6, where we have something different, then you can say, well, that's not the correct graph. So when it says crosses, it's going through here at 0. When it bounces or touches, it's just bouncing off and going in the opposite direction. Okay, let's do another example. Hopefully you have some room on your paper. I don't. Here. And we're going to follow through with the same directions. Find the zeros for each polynomial function. Give the multiplicity for each 0. Then state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. So here we go. We have here g of x is equal to -7 times x minus 8 times x plus 4 squared. So first thing we want to find, even though it's not asking us to graph it, I still just want us to kind of visually do this. What's the leading coefficient? No. How did you get 3? You have to count the other. Yes, you have to count the other factor. I'm going to tell you why. I want you to think about this. The leading coefficient is 3. Okay? And if you expand x plus 4 squared, this is my side note here. You expand that, that's going to give you x squared plus 8x plus 16. And then when you times x minus 8 to that, when you multiply that x and x squared, what would that give you? X cubed. So that leading coefficient will be 3. Think about it, because that's going to be your highest degree of that. When you, no matter how, if you distribute the x to the other term, the highest degree is going to be 3. Okay, not 2. We have to expand it. I mean, all you have to do, if you have factors, you have a binomial, and there's a specific binomial raised to a power or not, even if the power is not shown. Go ahead.
The degree is 3, right? Not the leading coefficient.
I'm sorry, the degree is 3. I'm sorry.
The leading coefficient is 1.
No, the leading coefficient is not 1. Let me explain. Cross that out. What I meant was the degree is 3. Let's clarify that. We all agree. Okay. So all you have to do, if you notice what we've done so far, you had terms. You didn't just have factors. See, these are factors. This is a factor, -7. X minus 8 is a factor. X plus 4 squared is a factor. So when these are not terms. It didn't say plus this, minus that, or plus that. Excuse me. But, so all you have to do, you don't have to go out and expand it. Just when you have the factors here, when it's a binomial raised to a power, just add the exponents. You got 2 and 1, that's 3. Now, if you want to expand it, you would do it this way. Now, the leading coefficient, I have leading coefficient. Let me scratch this. There we go. The leading coefficient is -7. Because after you've multiplied your x's and your 8, you're going to have x cubed. That's going to be your highest factor there with the power, your x cubed. Then what you would do, you would have all of this, and then you would times -7 to it. When you times -7 to x cubed, when we already said that our degree is 3, then our leading coefficient is -7. Okay? All right. So, so we have, what, an odd degree and a negative leading coefficient. What is our end behaviors? It's going to rise left and fall right. I still have all that information on the board, so if you need to look at it. Okay. Now let's find the zeros. This is where we're going to set our equation. This g of x, we're going to set that equal to 0. You're saying -7 times x minus 8 times x plus 4 squared is equal to 0. There's no need for you to try to multiply this and then factor it. It's already in factored form. All you need to do now is just set each factor equal to 0. -7 equals to 0. 4x minus 8 is equal to 0. Or x plus 4 squared is equal to 0. Okay, well, -7 equal to 0. Can we do anything to that? Well, we know that's not true. X minus 8 is equal to 0. What is x then? 8. Okay. That's an intercept. Okay. X plus 4 squared is equal to 0. To solve for x, we take the square root to both sides. The square root and exponent of 2 cancels out. We have x plus 4 is equal to 0. Now, we would normally say plus or minus 0, but 0 doesn't have a plus or minus value to it, so we just say 0. And then to solve for x, we would subtract 4 to both sides, and we get x is equal to -4. All right. So, next thing we want to do here is says we want to give the multiplicity for each zero. Well, we have 8 and we have -4. Say it again. Yeah, the multiplicity for 8 is 1. And when you're saying multiplicity, you're saying basically, and it says how many times is it repeating? How many times is x minus 8 repeating to give us 8? How many times is x plus 4 repeating to give us -4? Twice. So if you have an odd multiplicity, then will it touch or will it cross? And then when you have an even, it's going to touch and turn around. Okay, so that's what it's asking you to do here. Now, if you want to see the graph somewhat, okay, it's not perfect, so we have somewhat of a visual to this. Here is -4. Here is 8. So at 8 is what is going to cross. And we know that it's going downward. So cross 8. So something like, and then it's going to touch at -4. I mean, this is very rough. But just so that you can see, it looks something like that.